Welcome to today's webinar, Playwright Visual Testing Best Practices, presented by Applitools. My name is Heather Versillo, and I'll be your session host today. I'm also joined by Cory, a Playwright Ambassador and founder of React.js Consulting. Cory is a Pluralsight author, 11-time Microsoft MVP, and international speaker. So he's a busy guy, does this a lot, and is really great. But in addition to all of that, he has trained more than 10,000 software developers at events around the globe and has authored over a dozen courses on JavaScript, React, C#, testing, and web development. And with that, I think we are ready to go ahead and get started. Cory, I'll go ahead and hand this over to you now.
Very good. Thank you, everybody. All right, we're going to talk about visual testing. I'm going to begin by sharing my screen. So we're going to talk about Playwright visual testing best practices. And in this talk, I think a good way to kick it off is just to talk about automated testing in the first place, because it's a big tent. You have unit tests, and unit tests focus on testing one thing, one function, one component, one module, that sort of thing. And then we have integration tests, and integration tests focus on testing two or more things and how they work together. Often in integration tests, you might be doing mocking and those sorts of things. And that's an area that Playwright does really well. Then we also have end-to-end tests where you're testing, if say it's a web app, you're testing a browser all the way over to, say, a database. So lots of different tests, but in this session, we're going to talk about a very specific type of testing that Playwright supports, which is visual testing. Now, visual testing is fixated on what you see. So visual testing doesn't replace all that other stuff. It augments those things. And I'm a big believer that well-done automated tests involve balancing all these differences, because all of these practices, unit testing, integration testing, visual testing, end-to-end, performance, user accessibility testing, all these things are useful. None of them are a silver bullet, but all of them do help solve the key problem, which is having an application that's reliable, stable, fast, and so on. So our agenda today, we're going to start out by talking about why visual testing in particular is so useful and so popular. We're also going to talk about common problems and solutions that come with this. And in my experience, visual testing is one of those things that's interesting because when you glance at it, when you first use it, you go, oh, wow, this is so easy. But like anything, at first things seem easy, and then you look into the edge cases and you realize, well, there's a lot of nuance here. There's ways that I could get tripped up along the way. So the way we're going to format a lot of our conversation here is going to be in terms of problems and solutions. So I'm going to be sharing things that I've gotten tripped up on, and then the ways that I've solved those. Now, there's two approaches that we're going to talk about throughout this webinar. One of them is going to be using Playwright snapshots, and Playwright has built-in support for snapshots. So no real extra configuration you have to do. You can just dive in and start using Playwright snapshots. The other option that we're going to talk about here are using Playwright with a tool called Applitools Eyes. Now, Applitools Eyes is a service, and it also lets you do snapshots, but in a little bit different way. And it has a number of powerful options in there and configuration techniques. And so we're going to contrast these two, and I'm going to try to share some best practices that apply specifically to Playwright, some that apply to Applitools Eyes, and then quite a few that apply to both of these. So the real goal of this is to give you a sense of the benefits of these different approaches and a lot of common stumbling blocks that you might encounter and how I might suggest resolving those. Okay, so with that said, let's jump in and we're going to talk about visual testing. Now, why is visual testing useful in the first place? I think about how much visual testing is nice because it saves time. And of course, this is why we automate anything in the first place. In theory, we don't need automated tests. We could instead of writing tests, just go ahead and manually click around and look with our eyes. And why do we need visual tests? Well, it's the same reason we write automated unit tests or automated integration tests, so that we don't have to redundantly do these things. So imagine that we could automatically write tests that simulate what we're comparing with our eyes. And because of the way that visual testing works, it tends to give us a lot of coverage fast, because you think about how I can say, given this page, take a snapshot and then compare to it later. So that's a pretty powerful idea. And it means that I can go around and take snapshots of many different pages takes only a few minutes. And then right away, if that snapshot changes, I know that something visually is different. So that's pretty powerful, but there are also some nuance about how I execute that. So of course, the idea here is to catch visual regressions. I made this feature change, and if I didn't expect the user experience to visually change, I want to know about it right away. Maybe I changed some CSS and I thought I was just refactoring, and it turns out, oops, I have visually changed this page over here. I didn't intend to do that. I want to know about that right away. So this allows me to validate my styles and validate things like themes too, because you think about a lot of applications are themable now. And the most obvious example is people choosing light versus dark mode, making sure that these different permutations work. And as you get into these permutations, you think about how you're in the situation where you've got a matrix. And when I say a matrix, I mean you have to think about the combinations of light mode versus dark mode, and Spanish versus English, and feature flag on versus off, or maybe we're doing A/B testing. There's all these different permutations and combinations, and you think about doing that manually, and quickly this becomes rather impractical. So having an automated solution that can do these things in parallel, that can scale, is really quite useful. We also have things like layouts, and you think about today, somebody is using a phone, using a tablet, using a computer. All of these things have different form factors, and so you end up with a lot of different layouts that you might also want to visually test and make sure that everything flows the way you expect on different viewport sizes. You also want to just more broadly validate your responsive design closely related to this. Plus, we also have this issue of all these different browsers. I want to make sure that things look the same in Firefox and Chrome and so on. So this is another piece of that matrix when you start thinking about, okay, I want to know in Firefox on a narrow screen in this particular version of Firefox, when I have this feature flag on, now we have a visual bug. You could actually catch that in an automated test if you have those different permutations in the test. The other thing is you're going to catch accidental changes early. Like, I really like this. I want to know as soon as possible. And I'm a big believer that as developers, for us to be successful, we want things to fail fast and fail early. When applications fail slow, when code gets to production and we find out, that's scary. And it's unfortunate because it means that some user had a negative experience. And if we can catch that earlier, it tends to save money, save time, save reputation. This means then also that we can save time because it means we can refactor with confidence. So I could go in, for instance, and change my CSS and not worry about some other ripple effects. If I have robust visual testing coverage, I can say, I'm pretty confident in my change, but also now I've seen all my visual tests pass. So now I really do feel confident that I made a change that is safe. So ultimately, this is going to help us improve UX and accessibility, because the more that we feel empowered as developers to change the application, to improve it without worry about regression, the better UX gets, the better accessibility gets. So it feels like it avoids that feeling of having our code basically created in concrete because we're scared to change it. The more automated testing coverage we have, the higher our confidence, and thus the more we can iterate based on that feedback quickly. Okay, so for today, what we're going to do is look at a demo app. And I'm going to use this demo app so that I can show you just some different nuance related to visual tests. And what we're going to look at is a bank website. So to check this out, I'm actually going to hop over here to Chrome and open up a new tab. And we're going to go to Sandbox. And you'll notice what I just went to is a public URL. So if you're curious about what I'm doing here, feel free to go to this URL and you can tinker around as well. Now, we're going to focus in this session on this bank app. And this app merely exists just so that we can target something with visual tests. So don't expect this to actually work. So for instance, I can come in here and just click sign in. I don't have to enter a username and password. The goal here is to have something visual that we can look at. So we saw the login page, and now we're looking at a simulated dashboard for a bank. And This is useful too, because the moment that we look at this, you start to think about some of the different nuance and edge cases that might come up if I were to do visual testing on this page. So I want to make sure, for instance, that the logo displays up here. I want to make sure that these key pieces of information display, that they float in here properly, that they're styled in the correct colors, all these sorts of things. So what we're going to do is run automated visual tests against this particular page. Now, to do this, I'm actually going to come over here, and I want to begin by opening up my terminal. And I'm just going to hang out in VS Code here. And what I want to begin with is I am going to run Playwright. And when I run Playwright, I'm going to tell it that I want to run some particular tests. I have some visual examples sitting in this file, playwright visual examples.spec. Now, again, Playwright has snapshots built in. So there's no install that I have to do separately for this. I can just start running these tests. And we're going to see that Playwright runs some tests and then spits out a result here. Now, we can see that 2 tests passed, 1 test failed. So this is the traditional Playwright output. Now, before we go more into this, I really just want to focus on the fact that we have a little bit of code in here to run the test. And what this is doing is going to the sandbox app that I just showed you, and then asserting that this displacements.ping matches. And we saw that 2 out of the 3 tests have passed. This dynamic one did not. And we'll just put that on the shelf for now. We'll talk about some of this more in a moment. But for now, what I want to emphasize is just a little bit here. We're going to come over here to our slides again. And one thing that's really nice about Playwright snapshots, 2 lines of code. I say, go to this site, create a snapshot. And when I create that snapshot, I specify what I want to name it. So in this case, I'm writing an example test for the homepage, and I say, go ahead and create a snapshot of that homepage, call it home.ping. So quite straightforward there, 2 lines of code. And in fact, if we come back over here, what we'll see is I ran these tests. And what we have actually over here are 3 tests. Now, forgive me because this looks sloppy simply because I have some commented out code because I want to show you some different permutations here. But I want to emphasize that using Playwright really is just 2 lines of code here. It's nice. Of course, there's more configuration. There's lots of other things you could do, but the sort of hello world I'm showing you here is quite straightforward. And you'll notice that what we have in here are 3 different tests that I'm going to walk through. We're going to do a test for displacements and layout shift, one that has dynamic data and one that has subtle visual changes, just to show some of these differences. Then we also have one other test file that we're going to get to here in a moment. So notice I ran this, and when I ran this, I get files right here, and Playwright's spitting out these ping files. It's going to store them right alongside my tests, so I can see the output of these different visual tests stored as a ping, and these are used for comparisons. Okay, so that's sort of Playwright in a nutshell. The other thing that we're going to be looking at in our webinar today is how to do a demo instead, or sorry, before I pivot to that, let's talk about Playwright snapshots just for a second and some of the benefits of them. First off, they're free. It's built in, it's right there. You don't have to configure it. It's easy to get started. I know that I've jumped into an existing project, but just trust me, if you have Playwright, you can go write a test like that. And again, like any visual test, you can establish lots of coverage pretty quickly. It also runs locally, which is kind of cool. You don't need any network if you happen to be on a plane or a tunnel or whatever. It's going to work because what's happening is Playwright is doing those comparisons locally, so it's not making any requests. It's also just fundamentally simple. It's quite easy to understand. There's not a whole lot to it. Your files are stored locally next to the test, so you don't really feel like there's any sort of magic here. It's pretty traditional, and this is a lot like other sort of snapshot-based tools in its simplicity. And again, that's a trade-off. There are some benefits to simplicity, but there's also some cost to it, of course. And it is quite fast as well. As you'll see, like you saw, I run it and I get my feedback quite quickly. So it tends to scale pretty well. Okay, so that's our first option. The other thing that we're going to talk about in here is an alternative, Applitools Eyes. And I want to emphasize here one thing that's quite cool. What you'll notice is, again, 2 lines of code, just like in plain Playwright. The only difference is, notice that the import that I have up here at the top is pulling in a fixture. So if you're not familiar with fixtures, you can enhance Playwright with extra behaviors. And what we're doing here is saying, go to a site and then use Applitools Eyes to create a screenshot of that URL that I've went to. Now, much like Playwright, there's a whole set of configuration that I could do here. And also, if I don't know if you've ever looked at Applitools Eyes before, but this is a new API that they have radically streamlined. And I really like how now it's just so simple to get started. You can go in and configure it and override the defaults, but it has some nice defaults just built in that will probably work for a large portion of cases. So this can actually be a reality too. Okay, so we just saw, we came over here and we had ran our first little set of tests using Playwright. I also want to show then I could come in here and I could go ahead and run, instead of the Playwright visual examples, I'm going to run the Applitools examples instead, which sit over here in the same file. And what I want to show is the code itself. So it's going to run through these tests. And while it's running, I'm just coming down here to show. Notice here's the first test and the code in here. And in this test, I'm sending it to a URL, and then I'm naming the test so we can see those 3 passed. Now, one thing that's a little bit different is, yes, I can still click show report, and notice here's just a little trick in VS Code. When you get a command like this, see how it's underlined? I can hold down command and click it, and it will actually invoke that command. So I come over here, I get this report, and now you'll notice that the report page is slightly different when I'm using Eyes. I actually get a link to go see the Eyes dashboard. And then also when I click on these, I get this diff in here, seeing the diff of the actual. I could see the expected. And of course, these are grayed out because they matched. They are the same in this case. The test is passed. But if they happen to not pass, then I can come in here and approve, or I could come back over here and I could click on the Eyes dashboard, which gives me another view of this and gives me quite a bit more power too. I can see any of these tests and click on one of them, see the results, and then we'll talk in a moment about some of this other fun stuff in here, lots of other settings. So you can see you get a whole set of tools when you're using Eyes. Okay, so that's just sort of a high level so that everybody understands the basics of these 2 options. So now that we've got that high level, I do want to just briefly talk about just some of the benefits of Applitools Eyes before we go farther. So one thing is, you notice it integrates with Playwright basically with 1 line of code. I import the fixture and that's it. Now the rest of my code can end up consuming Eyes. One thing that makes it special is that it has AI for testing floating elements, dynamic content, layouts, and those sorts of things. And I know everybody's talking about AI now. I mean, you could just as well call it, it has algorithms for solving common problems in visual testing is maybe a better way to put it that doesn't feel so buzzwordy. But the point is, it helps solve some common tripping hazards that can occur when you're doing visual tests. The intelligence helps things scale. And that's what one thing that's nice here is Applitools helps visual testing scale because you don't have to fiddle with things like match thresholds or error tolerance, these sorts of settings. It stores and processes your snapshots in the cloud, gives you annotations, supports A/B testing, accessible contract tests, parallelized across multiple browsers in the cloud. And then when you're approving, you just click thumbs up. So you get this nice user interface for saying, okay, there's a diff here. What do you want to do about it? You just click and you're done. So these are some nice things about Applitools. But of course, both tools get the job done just in different ways and some different trade-offs to consider. Okay, so all that settled. The rest of this talk, I want to talk about problems and solutions. So the first problem that we're going to talk about is an issue called layout shift. And to give you a sense of what layout shift is, I'm going to bounce out of here and come back over here to our browser. So if we come back over here to the login form, notice that we've got this login form, and then I've got these little tools down here. And the cool thing about these tools down here is I can actually force this application to render in different ways. And I'm just doing this for demonstration purposes. So I'm going to say apply config changes. And notice that when I do this, it puts a little query string up here, and it puts this message up here above. So basically, when this query string's in here, it's going to render this message above. So this is merely here for demo purposes. But the reason this is important is now I want to be able to show you how the different tools behave in this situation. So we're going to come over here, and earlier I had run through Playwright's tests in here, and I generated these images. And actually, just for the moment, I'm going to go delete these and just kind of give us a clean slate for a second so that we have a good baseline. So I'm going to come in here and rerun the Playwright tests. So it's going to generate a baseline using these existing. And what you'll actually see is when I do this with no images, it's going to say, hey, none of those applied right there. So then I need to actually update my snapshots to get this to take. And with Playwright, I can say, update snapshots. And there we go. So now notice that it says all passed. So what I told it was, hey, those new baselines that I just generated for these are all set. So we're good there. And you'll notice that when that happened, it generated these files, and we have all this sitting over here. Now, just looking for a second. Okay. So the first one we're going to look at here is this layout shift. And this is written to a file called displacement test. And I'm sorry, I'm looking at the wrong file. Let's go over here to Playwright for a moment instead. Okay, so we're going to look at this displacements layout shift right here. And that's written to displacements.ping. So we have it over here. And we have this file. So this is what we expect the application to look like. Now, what if instead I come over and I uncomment this and we rerun the application, but this time we run it with that banner across the top. So I'm going to go ahead and rerun my tests here, but I'm not going to put update snapshots on. Now, when I do this, Playwright is going to do a comparison, and it's going to say, okay, so previously screenshot had just the login, but now it doesn't. So I'm going to click in here, and you'll notice here's the diff that we get with Playwright. And what it's showing is quite a bit of red, and that's happened because when we put that banner across the top, the layout gets moved in such a way that it makes the diff rather confusing to look at. And this is one of those cases where actually a side-by-side I find is much easier to read. So one suggestion that I have is if you're dealing with any kind of layout issues, use the side-by-side view in Playwright, because this makes it obvious. You go, oh, okay, well, it looks like we've added a new feature where there's a banner across the top. So it's not like everything changed. It's just that now we've got this new thing across here. So that's the difference. Now, there's a couple other ways that you could think about this as far as best practices. If I come back over here and go into my slides, when you deal with layout shift, one thing that you can do is snapshot subcomponents instead of an entire page. So the reason this layout shift occurred at all was I snapshotted the whole page, and that means if anything changes to move anything around, now the whole page snapshot ends up showing a diff and it's broken. Well, if I had snapshotted just the login component and then separately snapshotted that banner across the top, then I wouldn't have had this layout conflict. So that's another way that you could resolve this. Now, another way that you could handle this involves us pivoting over into Applitools for a second. So let me show another way to handle this. We're going to go into the Applitools file. And we've already got our baseline configured here. So I'm going to comment it out, and I'm going to show an alternative approach. So with Applitools, we're going to turn on that setting to create that banner that sits across the top, and it creates a displacement. But when I run this, I want to show how this lays out. So we're going to go over to run the Applitools test. And what you're going to see this time is notice that this test that I've written for Applitools says ignore displacements false. So I'm telling it not to ignore displacements. And that means then that we come over here and we'll see these results. And again, I can click on the report and we see the report and see how this marks in orange, which is saying, something's up here. We look side by side and we see these side by side. And you'll notice it sees this difference. And if I go over here to the diff mode, we can see things show in purple in this case instead, but we get this similarly jarring looking diff, and it's intimidating. Well, if I come over here and I tell it to go ahead and ignore displacements, so now it's going to think about things in a different way. I'm going to be running a different diff algorithm. Let me show the results. We're going to rerun this. And now that I have ignore displacement set to true, it's going to think about this in terms of, okay, if things merely get displaced, that's not a problem. That shouldn't end up breaking everything. Our diff is going to be easier to read now because we're using effectively a different diffing algorithm. So I'm going to click on show report again. And now when I come back over and I click on layout shift, we still see side by side this difference. But when we go to the diff, notice how much clearer the diff is now, because again, we said ignore displacements. Now it just shows, hey, there's this new thing at the top. So this diff view becomes easier to work with, a little bit clearer what goes on here. And again, if I came back to here and I go over to the Eyes dashboard, this is another way that I could handle this. We can see it shows in orange. I can come in here and click on it, and I can actually click on highlight this. It takes me right to it. I can also click here and it highlights the particular pieces that have diffed, so I can see it this way. So a few different tools in here to make that happen. So that's just an example of how you have some extra configuration to improve that diffing experience. Okay, so that's number one, a couple ways to handle layout shift, and either break things down into subcomponents, use that side-by-side view, or in Eyes, you can ignore displacements, which is another nice way to go that improves that diff experience. Okay, so we just saw the demo of layout shift. All right, let's talk about another thing that this comes up all the time, and it's probably the single biggest pain point that I've experienced when dealing with visual tests is dynamic content, because it's the nature of almost every application. We're calling a database, that data changes over time, maybe are showing different ads, different dates, different numbers, user-generated content, all those sorts of things. Well, as far as solutions go on this, there's a few, but before we get into the solutions, let me just show you what I mean. If we come over here to our app and I go to sign in again, what if I come in here and I say that I want to, I'm going to clear for a second. Well, where did my settings go here? Refresh here because I don't see it. I'm going to take this out and go back to the dashboard. And I don't see the dynamic setting. It has disappeared. Let me do it this way. So, oh, that's it. Okay, it's actually got a different name. I need to do it like this. That's what throws me off. Okay, I forgot about the name for the setting. Sorry about that. So here's what I want to show. Notice every time I refresh the page, it is now with this little query string up here to force the application to do this interesting behavior. This simulates reality. Like every user is going to have a different balance, and day after day, the database is going to reflect different balances. So then the question becomes, well, if I do visual tests, now these are going to fail all the time. So if I came over into Playwright, and in Playwright, we'll go ahead and collapse this first test, and we'll come down here to the second test regarding dynamic data. Well, what we can do in here is actually mask this particular value. And in fact, I have Playwright configured with this mask right here. And what I've said here is go find anything with this admittedly ugly CSS class and mask it. Now, when I do that, you'll notice that over here in Dynamic, see how we get these pink boxes? So this is me telling Playwright, I want to take a snapshot of this whole page, but ignore these pieces. So this is a nice way in Playwright to be able to have a test that will still be reliable, even though you have some dynamic data. Now, of course, there's a bit of a trade-off here because we aren't actually checking to make sure that exact number is there. So the best practice here is to remember that visual tests are not a silver bullet alone, that we still need to write integration tests, end-to-end tests. And what I would do in this case is I would write an integration test. I would mock out the back end, and then I would assert that the right balance shows in the right spot and the right credit available shows based on my mock data. Now, the other thing that you could do, which is kind of cool, is you could actually have some query string that is used just for testing purposes to force data as well. It's another way to think about it. But what I would actually typically do is mock. One other thing that you could consider to avoid having to mask here is to just have a test database that you reset before each run so that this data is reliable. So that's another way that you could choose to handle it with plain old Playwright. So lots of ways that you could slice and dice this. Now, I also want to show, though, that it's a little bit different over in Applitools. There's another way that you could think about handling this is we're going to collapse this first test here, and we'll talk about dynamic data here. So I'm going to come in and comment out this second option here. And you'll notice that what I'm doing in this test is just changing up all sorts of stuff. We're finding an element, we're changing the color to red, changing the style to black here. We're finding some specific text and then changing actually the label of it altogether. But what I'm doing in Eyes is something interesting, which is called a match level of layout. So when I rerun my test here now with, oh, hold on, I'm not ready to rerun it because I need to comment this out. There we go, because this is the new version of the test I want to run right here. So let's pick this open again. And what it's going to do, this test is going to go to that site. It's going to enable that dynamic data that I just showed you. And it's also going to come in and change up some different styles, change up some content as well, even changing the text in here. But I'm going to do a match level of layouts. This is a way that you can configure Eyes just with this second argument here. We have various parameters that we can run. And you can see this test actually passed, even though I changed this stuff. So we're going to come over here. Now, when you say it passed, it's still unresolved, though. We have to come in here and we can see that now, oh, I'm sorry, this is actually this is actually the different test. This is not the one that I had intended to click on because we're talking about dynamic data here. And the dynamic data does pass. Here's what I wanted to show. Okay, so see this side by side? I'm going to zoom in a little so we can get a sense of this. Because of the way that I configured Eyes, I told it, hey, I'm just interested in the layout. And this is a really powerful idea because the algorithm that we get here says, I'm not going to really fret about the content inside of here or here or here. I'm just looking at that this layout is correct. So now this test would certainly fail if the layout were different. And you'll notice that it actually does even allow for this to be a different color, that the logo is red rather than on a green background, because I just said I'm worried about the layout and nothing more. So there is a trade-off at play here, because now I have a little less confidence that it's doing exactly what I want, but I also have more power. It's not going to flake out just because some data changes. So this gives you a sense of yet another way to handle these sorts of dynamic situations. Okay, second the clock. We got a few more minutes. I want to show one more little thing here. I could have hidden this too. Okay. So one more little demo. I want to talk about just general test flakiness, which is the other big pain point that can often come up when you're doing visual testing. And there's lots of different ways to address this as well. First, when you're talking about just Playwright specifically, I encourage people to start small. It's really tempting to say, all right, I'm going to go write a snapshot test for the entire page and then go to the next page and snapshot the entire page. But the problem is, well, when the test fails, now the test has failed and the scope of that test is huge. It's like anything that changes on that page is going to break a big test. And it's a bit like when somebody writes an automated test. Ideally, that automated test fails for a small number of reasons. The longer the list of potential reasons, the harder it is to figure out exactly how to fix it. So I encourage you to start small, maybe snapshot individual pieces. And this is where tools like Storybook can be really useful, because Storybook lets you run components in isolation. So I'm a big fan of that. And you can target your visual tests there first and get good coverage on important pieces like, does my button, does my tab control, does my accordion render as I expect it to with all the different permutations of props? Another thing here is just to focus on key static areas. And I emphasize the word static here because, of course, if something is static, you don't have to worry about masking it. You can reliably know that it's always going to pass that test. Another thing here is you need to experiment. And unfortunately, there is no right answer for these configuration settings in Playwright. In Playwright, when I'm using snapshot testing, I can configure max diff pixels, max diff pixels ratio, and threshold. Now, the thing with these settings, if I set them too high, too strict, then I'm going to end up with flaky tests. And if I set them too loose or too low, then I'm going to end up overlooking changes. It's not going to catch things. So keep in mind that you're probably going to want to set these per test in many cases, because there's no perfect answer here, and you'll have to think about the nuance there. Now, the defaults that Playwright includes are quite useful and cover many cases, but they're unlikely to work everywhere for you. So I would encourage you, don't feel bad about having to override these on a per test basis in time so that you can get more stability. Now, the other way to think about this, though, is just also avoiding over-reliance on visual tests, because again, think about visual tests as a piece of your testing puzzle. And if you're hitting things that you feel like are really hard to visual test, then, well, maybe lean on an integration test or lean on some mocked out data. Think about other orthogonal ways that you could solve that problem. So that can be another way to go. Now, another thing to consider here is if you happen to be using Eyes, this is part of the big benefits of Eyes, is that Eyes has its own algorithms that mimic human vision. So like I just showed you, you can actually ignore any changes that are invisible to the human eye. Like by default, it is able to figure out that, okay, even though a few pixels might have changed here and there, and those pixels might have changed because perhaps a new version of Chrome came out, some new OS happens to render slightly differently, it is smart enough to mimic human vision and avoid flakiness there. So that's one of the big benefits of Eyes that I really like, is it avoids me spending time trying to get these specific settings right. Because again, there's no right answer for max diff pixels or threshold and these sorts of things. You have to think about the nuance on a case-by-case basis. So that's one of the benefits there. Okay, so a few other things here. When you're dealing with subtle changes, oh, I'm sorry. I'm going to skip past this demo just for the sake of time, because I want to make sure we get through just a couple other points here. Another problem that you'll often see, cross-machine flake. Now, when you see this, it's often because of this very version. Sometimes I'm running a different Playwright version than you are. Maybe I have upgraded, maybe I installed the Playwright browsers on my machine and I end up with a slightly newer version of Chrome or Firefox than one of my teammates. And that can mean that when I run the tests, now my tests end up failing because they're using a newer version that renders slightly differently. So it's really important to make sure everybody's running the same version of Playwright. And so another way that you can think about doing this is to run your visual tests on the same hardware. And one way to do that, of course, is to use CI as the place that you do that, rather than constantly relying on local. Now, of course, there's some trade-offs here because you're getting a bit of delayed feedback, but the benefit is if you're running them on CI, at least your CI should have a very stable OS and stable set of browsers, as long as you're not regularly updating Playwright. And that speaks to my other recommendation is Playwright is wonderful because it's well supported by Microsoft. They're always putting out new good stuff, but I would avoid doing really frequent Playwright upgrades, because when you do, it can sometimes lead to your snapshot tests changing because you might get newer versions of browsers. So you might think about doing it on a cadence that you think justifies those trade-offs. Like, yes, I want the new good stuff in Playwright, but also I don't want to end up breaking visual tests very often, potentially. So that's when I think about a cadence, kind of like upgrading NPM packages, like maybe every few months rather than as often as I can find any new like dot version, for instance. The other thing that's cool with Eyes, at least in this case, is Eyes has an interesting algorithm where it will use the previous version of a baseline if no baseline exists for that new version. So that can avoid this flake together, this issue where if we have different OS versions installed on our local machine, we can avoid that flake. So it holds on to those previous baseline versions and can make those comparisons. So it basically just works in a way that's transparent to you, and you don't actually experience this this friction. So really like how that works. Okay, another issue when we talk about tests, sometimes visual tests are just hard to debug. And I've thought about this like using just snapshots years ago, that sometimes the snapshot would fail and I'd go, well, I'm not sure where to begin because there's just all this different code in here. So one thing that's really important is to name a test clearly and hopefully specifically. Now, I know my examples were taking entire page screenshots, but remember, we can take screenshots of portions of a page or of particular components, and that can help clearly convey intent. And I would encourage you to consider more focused tests rather than testing on the entire page. Another thing here, maybe you have this problem with A/B testing. Well, one thing that you can do in Playwright, maybe you have two different versions of your application and you want people to be able to see how this feature works versus this different implementation or different visual styles and things. Well, you can actually set up your application to force A versus B using a query string, or also known as a search parameter. I could say show A or show B, and that way in my test, I can write a Playwright test that says when scenario A is enabled, here's the screenshot. When scenario B is enabled, here's a different screenshot. Another thing that you can do though in Eyes is Eyes actually has support for A/Bs in screenshots, which is pretty cool because if we come back over here, like I can come back here to the results in Eyes dashboard here. And what I want to emphasize is I can come in here and click on the test. And I could actually create an A/B of this. So imagine I say, okay, this is one version of it, but then I can click create new here to create a new baseline and call this with banner here. So now I have two different versions of this page. I have version A and version B. This way, both can end up passing. So I have just support built in, which I really like this too. And while I'm in here, I'll just draw attention to a couple other things that you get in Applitools that's cool. I can do annotations. I can come in here and annotate, add certain comments along the way to point this out, to give people ideas. I also have all this power around very nuanced ideas around regions so that I could ignore a particular element, or I could say that it floats. And that way, as long as it's floating around in a way that the algorithm expects, it won't flake the test. I can mark something as dynamic to say this little area is going to contain dynamic data that changes over time. Or maybe I can say within this region, I don't care whether this is red or blue or green, just ignore the colors right here. Or I can just say, hey, all I care about is the layout, which is what we did here, and that ends up cleaning up the disk. I can add a region where the differences will evaluate at the layout match level rather than pixel for pixel. So that tends to be useful. One other thing I'll point out here is you have accessibility checks in here too for WCAG2 and 2.1, being able to check your contrast levels, and you can change AA or AAA in here too. So lots of other features. I can't get into them all just due to time, but the Eyes dashboard I find quite handy. Okay, one final thing here, and then we'll get to Q&A. So sometimes you end up with merge conflicts. One way you can do that in Playwright is you end up resolving the diff locally and then push. And this is an area where Playwright can create a little friction, because if you're in GitHub, you're actually blind because you can't diff images in GitHub. So what I encourage you to do, my solution here is handle that diff locally. And sometimes even you might want to need to go pull that image from main if you're on a feature branch. So switch over to main, copy that image, switch over to your feature branch, and you can paste it over to resolve that diff. Now, this is one thing that Eyes makes kind of handy. Eyes actually has a dashboard for resolving those diffs. So this is a little preview of it here where I can just click around, use this, see the images side by side. So when merge conflicts occur, it's a little easier to resolve there. So I'm a fan of the extra developer ergonomics that you get in this case. Okay, one last thing. What if you have slow tests? Well, you can maybe test in fewer browsers, or you could only run visual tests on CI or main, run them less often, maybe on a schedule, those sorts of things. Or I'd encourage you, think about parallelization. Try to run lots of tests at the same time. And this is, again, I love how Playwright supports parallel tests. That speeds things up. And also Applitools supports the same thing. Now, Applitools takes this even a step farther because it takes one screenshot and then it can run that up in the cloud, and you can run these checks against a bunch of different browsers all in parallel at the same time. So you get to select how far you want to go with parallelization. And that's part of where Applitools tends to scale really well, because you can end up leveraging so much of the power of having this cloud solution rather than running things on your local machine. So in summary, these are two great ways to handle visual testing. Playwright's benefits are it's quick, it's simple, it's built in, and it's really easy to get started. No configuration, no installation, because it's part of Playwright. And then Applitools, what I really like is how powerful it is. It's reliable. It tends to have tools that help reduce the amount of flake that you have. And it also avoids that tricky problem of deciding how sensitive I want to make my tests on a pixel level, because it uses algorithms rather than pixel level settings. So I have things like dynamic data and layout, and it is mimicking more what my eyes see rather than thinking on a pixel by pixel basis. And that tends to make it more scalable. I like all the configuration in it, but I had great success with both options, so worth considering. Okay, so I'm going to stop here and accept some Q&A, but I will say you can find me on Twitter. I'm House Core. I've written a bunch of courses out on Pluralsight, and they have a free trial if you're interested. I also feed my kids by doing consulting and software. So I specialize in automated testing and front-end development with React, so you can find me at React.js Consulting.
And I see a lot of really great questions in the Q&A panel. So we're going to try to get to as many as possible during the time we have left together. But if we don't get to your question, don't worry. All of them have been captured and will be captured if there are more. And we'll be sure to share them with our team so that we can follow up. That being said, let's take a look at our first one here from Patrick. And Patrick's asking, how do you deal with waiting for components to load any requests? Like wait for load state, according to the Playwright documentation, it's not really recommended for testing.
Justin, do you want to speak to this, or should I?
I will defer to you on this one.
You'll defer to me. Okay. So, there's a couple of things that I think about here. Anytime that I'm dealing with the loading state, recognize what I was saying earlier, where you also have this opportunity to think about testing your components within Storybook. So this is one way to get around it altogether. So imagine that your component in the application has a spinner, and that spinner shows until, well, some other data shows. Well, if you run a visual test against Storybook, now you hold all the cards. You don't really need a spinner at all. You could put it in a loading state via, say, a Boolean, or you could end up showing it with actual data. So you could have a visual test for loading state and a visual test for the final state. So that's one way to go. Other things that you could consider is, if I'm going to do a visual test for the actual page, then, well, maybe I end up even having some dev tools for this. Like that app that I just showed you was doing something that I love. And I know this is a separate conversation, but the idea of building dev tools for your application just to make your developers more efficient and to make your tests more powerful, I'm a fan of that. So I would even perhaps have little settings that let me say, well, I want to force the loader not to display, or I want to force the loader to stay, or I want to simulate a situation where I have a slow loading situation or fast. And again, those are even not necessarily tied to visual testing. It's a broader idea of maybe I want to slow the app down so that I can test its behavior on a slow situation. And in other cases, I want to simulate that I have no wait at all so that I can do a visual test without that loader even showing. So lots of ways to skin the cat in that case.
Thanks, Cory. That was helpful. Our next question is about dynamic data. And Mashu, and I apologize if I mess up names, but they're asking, what about dynamic data? It seems to be validating with a screenshot. What if I log in with other users and data is different? Then I'd have to, again, use one more screenshot. What if I use hundreds of users? Am I going to store 10 different screenshots?
Yeah, and this is where you have to think carefully about what your use cases are, what your data test cases are, and also how far to go with this. Because just like if I was going to write automated tests for any application, I'm not going to write automated tests that make sure all 1,000 users can log in as individuals, because it doesn't scale. I'm not. You can imagine, for instance, Amazon can't write tests that make sure that I can log in and Justin can log in and Heather can log in. What they do is they make sure one example user with a certain config works as expected, and then they start thinking about different permutations. Like maybe if I'm Amazon, I want to make sure that a user from Oklahoma and some user from Texas can both work through the checkout process, because they might have different user behaviors. So it's really just about putting guardrails up and saying what my goals are. In the end, the only reason I need another snapshot is if I'm expecting a fundamentally different behavior. And that helps you avoid creating hundreds of snapshots, and instead, hopefully creating a rather small number, and in many cases, maybe just one.
Thanks, Cory. All right, let's take a look at our next question here. All right, so Ani's asking, when saving a snapshot in Playwright, tests often fail due to pixel differences, even on the same machine, browser, OS, and resolution, since elements can shift slightly. Is Playwright planning to resolve this for more stable snapshot testing?
So this is the fundamental pain point of doing local image comparison. This isn't unique to Playwright at all. This is precisely, in fact, why Applitools and other alternatives exist. Is the moment that you're running snapshot tests locally, getting the sensitivity right is really difficult. And in fact, I've worked on teams where I had a MacBook Pro. My coworker had a MacBook Pro. They were both M1s. We were both running the same almost exact version of the OS, but we would sometimes get flake. Now, that flake exists in many cases because we have the sensitivity turned up too high, but it also sometimes exists because there are subtle little differences between our hardware or our software that we're not realizing. So one thing that, of course, you can do is turn that sensitivity down some, and then you do have to recognize, though, that the trade-off you're making there is you're going to have less flake, but you also have a little less confidence. And unfortunately, again, I'm not trying to dunk on Playwright in any way, because that is just the fundamental nature of doing comparisons of images on local machines. And the reason Applitools exists is, what if instead we did these comparisons with an algorithm that sits on the cloud? You can run your comparisons in the cloud on the exact same hardware every time. And one of the things, just for the use case that you had right here, maybe consider running your visual tests on CI. And that way, at least if they run just there and you sort of ignore local, then you at least have a consistent piece of hardware there that should help resolve some of those flake issues.
Yeah, definitely. And just to kind of add to that is, yeah, I mean, just what we do here at Applitools is we specialize in visual testing, and we have algorithms like Cory mentioned during his presentation, like our strict algorithm that detects visual differences that a human can see. And so what we also have are mechanisms based on our baseline. So our baselines capture all the environment information, like the OS, the browser version, and so forth. We also have a baseline fallback mechanism. So if you go from one browser to another, or another user's tested on another machine or a different browser, it will actually compare against that baseline that was captured before. And all you have to do is review the changes and approve or reject them. Additionally, we do have like algorithms like layout that Cory also demoed, and we also have dynamic match level algorithms that can check for different dynamic text or values of numeric values or so forth. So we have a lot of tools built in to do visual comparison there.
Our current question from Andre is, what if the UI you are automating is a highly sensitive website and there are security concerns around uploading any artifacts to the cloud?
Sure, yeah, I could answer this. So yeah, we here at Applitools, we have lots of enterprise customers, both government, insurance company, banking, and so we offer different cloud services. We have public cloud, we have on-prem, so everything's installed on your hardware, and we also have a dedicated cloud, so hosted on Azure, Google, and so forth.
All right. Shika's asking, can we automate dynamic visual elements?
Yeah, so I can answer this too. So I think Cory touched on it during his demonstration, but And I just mentioned it before, we do have different algorithms. So our layout algorithm can check the layout of either the entire page for any dynamic data and ignore it, or you could do specific regions. So if you only want to say, for example, you want to capture just a modal, a region of the page, you could do that and give it a layout algorithm. And we also have a dynamic algorithm to essentially put a mask on any text value, any numeric value, and not fail if those values change.
Okay, and Sabine's asking now, is there a way to have UI designs like Figma's design be the baseline? If yes, how?
Okay, we get this one a lot. Yes, it's a popular one. Yes, it is. It is possible. So in Applitools, we have lots of different SDKs, including this Playwright one we're talking about. So it is possible with different approaches. We also have a Figma plugin to upload your Figma designs as a baseline, and then you can capture your implementation or your local host or your live website to compare against that Figma design.
Perfect. Mike is now asking, I might have missed it, but with the Playwright snapshots, is it just simply that a screenshot of the page but no comparison is done to validate if changes were found?
Yeah, so either I could answer this or Cory, but yeah, maybe we missed it as part of the demo is, so with the Playwright, the to-have screenshot function, it will capture a PNG of the page that you're testing. So you have to run it twice. So the first time it captures the baseline, the second time you run it again, it will then compare against the second execution and show you the visual differences.
Yeah, and that's where I was pointing out. Remember, at one point I had the diff and I showed that we had the layout issues and it showed that diff. That was coming straight from Playwright. So, what Playwright's doing is taking the saved ping that we saw there and then comparing it to the one that we just generated from the test run. So yes, and that's exactly how we get those diffs in the test runner results.
So Brett's asking, what are the most common visual testing pitfalls and how can you mitigate them? This is a big question.
It's a loaded question.
Yes.
I could give part of it, and then Cory, if you want to add anything additional. And again, Cory, I think touch on this during this presentation. But yeah, the pitfalls are just like any testing. It's coming out with deterministic settings or setup of your test to make your testing successful. So what does that mean? That could be like seeding your data, making sure your data is consistent whenever you're testing. Whether you're using APIs to do that, pointing to a database, or just mocking the data, those are going to give you the best results because to mitigate those, we touched on it before. We do have different algorithms to handle it, like such as using layout or our dynamic match level, and we also have a color match level to ignore colors. So there's definitely different things that can happen.
Mm-hmm.
Yeah, I would echo all that. I'd also just emphasize in many cases, it can just be helpful to think small rather than big to avoid. I know it's easier to go big to say, all right, test all the things, but being more focused, naming things clearly. And I find if I'm naming it page, that might be me thinking too big. Early on, I like to think about a foundation of focusing first on the reusable components that we have, because those are going to be quite straightforward to visual test in comparison to a big page, and thinking more modular about my tests rather than bigger picture can also help there.
Yes, I agree.
Yeah. Comes down to prioritization. And this is from John, and John's asking, do you think visual testing makes sense with charts?
Well, I would say absolutely, because charts are visual. Like it's maybe one of the most compelling examples to me. Now, I think probably what you're getting at, John, is thinking, well, how do I do a visual test on a chart that changes over time? And my answer would be very similar to the other dynamic data that I was dealing with, that I would mock out the API in it, for instance, so I can always get the same data to populate that chart, or I might end up testing that chart in isolation via tools like Storybook or Ladle. That way, what I really need is just determinism, just like Justin was saying. So as long as the data is reliable, then my screenshot can also be reliable.
Tons of great questions today, and I want to thank everyone who joined us today, and especially Cory for presenting and sharing your knowledge and strategies. We incredibly appreciate that. One last note for everyone is just quickly about Applitools. We do provide AI-powered tools for visual and end-to-end testing that lets your team of any skill level create and execute and maintain powerful tests that validate more of your app, even in the most complex scenarios. And that can happen across more screens and devices in less time. So I know we've had a number of Applitools customers that have joined us today. So if you want to take advantage of some of the sessions or the strategies that Cory has shared, you are welcome to schedule a session with your account team. And if you are new to Applitools or just learning, you can try out some of these strategies that Cory has mentioned by signing up for a free trial of Applitools Eyes. And that's at applitools.info/4LZN. Thank you everyone for joining us. We hope to see you again soon.
Thanks, everybody.
Yeah, thank you.